Okay, looking at example 3, we have Cynthia bought a rookie baseball card in 1997 for $2.60, and then the value of this card is expected to increase at a rate of 6.5% per year. So we know that the card is increasing in value. So one thing that tells me is that this is going to be an example of an exponential growth since it's increasing. And it tells you the rate at which it's increasing, so I know that it's increasing at a rate of 6.5%. So that'll help us figure out what the actual growth ratio will be instead. And so it says, write an equation that models the value of the card after t years. So let's start with the general equation, y equals a times b to the exponent x. And we know what the initial value of the card is. It was $2.60. And we know that the growth ratio will include the growth rate that we are given in the question. And we're also told that it increases in value on an annual basis. So every year it increases by 6.5%. So we're looking at the value of a card over time. So I know that my dependent variable is the value of the card, and my independent variable is the amount of time in years. So I'm going to write V of t equals the initial value, which is $2.60, multiplied by the growth ratio. So my growth ratio is going to be 1 plus the growth rate as a decimal. So 0.065 is the growth rate as a decimal. So remember, whenever you're looking at growth and decay ratios, they always depend on the growth or decay rate. And so in this case, 6.5%, which is your rate, as a decimal can be written as 0.065. Okay? So my growth ratio is going to be 1.065. And my exponent in this case is just going to be t because it increases by 6.5% on a yearly basis. Okay, part B says determine the approximate value of the card in 2010. So because the value of the card in 1997 was $2.60, then that tells me that 2010 is 13 years later, so t equals 13. And so we're just finding the value of the card, so we're just going to take the equation and plug in a value of 13 for time. So we get $2.60 times 1.065 to the exponent, 13. And if we solve that on our calculator, we get $2. Oops. I meant to type that into my calculator. $2.60 multiplied by 1.065 to the exponent 13 gives me an answer of about $5.90. Remember that we're looking at money. When you're looking at money, you need to round to 2 decimal places. So therefore, the value of the card is about $5.90. Don't forget your dollar sign. That goes with your communication. Okay? Part C says determine when the card will have an approximate value of $10. So here I'm given the value, and it says determine when, which means I'm solving for a time. And so I'm going to use the equation again, and because I know the value, I'm going to substitute it in for V of t, and I get 10 equals $2.60 multiplied by 1.065 to the exponent t. And just like the other questions that we've been looking at, anytime you're trying to solve for an exponent, you want to get rid of the coefficient part that's in front of the exponential part. So I'm going to divide both sides by $2.60. And I'll get 1.065 to the exponent t equals $10 divided by 2.6 gives me about 3.846. I'm going to round it off to a few decimal places. So about 3.8462 approximately. And again, in order to compare these two numbers, I need to have the same base. So I'm going to rewrite the left-hand side, the one that doesn't have an exponent on it, with the same base as the one that does have an exponent on it. So I'm going to rewrite 3.846 as 1.065 with some exponent on it. I'm going to try to solve for the exponent now. So let's play around with some numbers. So 1.065 to the exponent 5. Okay, that's too low. 1.065 to the exponent 10. Still too low. 1.065 to the exponent 100. Whoa, way too high. 1.065 to the exponent 20. Oh, that's pretty close. So 1.065 to the exponent 21. Getting closer. 1.065 to the exponent 22. A little bit too high. So 1.065 to the exponent 21.5. That's pretty close. So this is to the exponent about 21.5. Okay, so the left-hand side I can rewrite as 1.065 to the exponent 21.5. And that's approximately equal to 1.065 to the exponent t. And so because the bases are the same, I know that the exponents must also be the same. So I get about 21.5 is approximately equal to t. So that's 21.5 years. So therefore, the card will have a value of $10 in the year, I'm running out of room here, and so 21 and a half years after 1997 would be the year 2018. Okay, so halfway through the year in 2018.